Before we start today's session, let me give you some information because I already scheduled the final exam, so it will be the next Tuesday. This day at it was 16th of May. Okay, it will be 16th of May. I thought that this time you will get total 40 questions, and you will get 1.5 minutes to complete each question, and you will get total 60 minutes to complete this question. All right, or 1 hour. Also, hopefully today we'll complete our syllabus. If it is not, then we'll continue a little bit for this next class Thursday. But hopefully today we'll complete our syllabus. And next Thursday I will be here. I'll be here on campus in Zoom. So if you have any question for regarding any topics, you can ask me. I'll be here. But let's see that today we can complete or not. Okay. Okay. Let me share my screen. So in our last class we talked about the some topic on hard disk drive. What is the configure? How actually hard SSD drives works? That things I showed you, especially for seek time. Seek time is nothing but the seek time is nothing but movement from movement. This is if it is this is kind of track on hard disk platter. There could be several of tracks, and then here also there is that there could be some several of platter inside the hard disk drive. This is platter. Also this is known as this track. This is if it is 0, this is 1. If it is 0, also this is also 1 number track. Okay. Track inside this track, this is known as this SSD block or SSD sector. So this is SSD sector. If we join this 0 track to 0 track, also this 1 track to 1 track, so it also known this when you join, then its shape is like a cylinder. Okay, this shape is like a cylinder. So this is called the hard disk cylinder. This is also one cylinder as well. This shape one cylinder. Here is also one cylinder shape. When we join 2 track between 2 platters, between platters. If it is 3 platters, then you can join these 3 platters. Then it will be a cylinder shape. This is called the cylinders. So what is the seek time? Let's say your SSD head, your SSD read-write head. In every plotter, it has kind of read-write head. Okay, read-write head. So if your SSD plotter head is in here, the time taken to move your SSD head from one track to another track, this is called the seek time. Seek time. Okay, this is seek time. Also, once this kind of head movement means that also the cylinder movement, this same thing. You know this kind of, if you consider this way, this is also one cylinder, this is also one cylinder. When your one SSD moves from one track to another track, all SSD head will move from the, let's say currently your SSD head is track number 1. All SSD heads initially is track position 1. Then it's moved from track position 1 to 0, 1 to 0, 1 to 0. So all read-write head of each platter will move from track number 1 to track number 0. Only one head will perform this read-write. Let's say this head will perform this read-write. So but all head should move from track number 0 to 1 to track number 0, track number 1 to track number 0. So this is nothing but a cylinder movement. This is track as well as the cylinder is same. This is if you consider this is track 1. Also this is the cylinder 1. This is cylinder 0. This is cylinder 0. When you connect this 0 number track together from upper platter to lower platter, this is also cylinder 0. This is cylinder 1. This shape is a cylinder one, or kind of like this. This track movement is nothing but to similar as the cylinder movement. Now let's see that you read right head. Then let's see you have. Let me give you one example. Let me give you an example. This is, let's say, this is one SDD surface. This is track number 0. This is 1. This is 2. And also this is 3. And then you have total, let's say total, I don't read all of these things. This is 3, and then till you have total, let's say 200 track inside a platter. So last track is, let's say 1. This is, let's say, till here. This is, let's say, last one would be 199, and this one, if it is 200, total 200 track, it is from 0 number track till 199 track. Also inside, let's say this is will be also 198 number track. Okay, 100. This is 198 track. Okay. Now let's see that you receive some you receive some command, a command to read the data from, let's say, track number 2 from different process, 199, and the number 0 number track, as well as the 198 number track, and also 1 number track. This is the order you receive there to read the data from this SDD track. Okay. Also, let's say this initially you read write head position is track number. Let's say track number in here, track number 3. Okay, track number 3. Initially read write header is position is in here. So now let's see that how it's how actually read write performance work. So track initially you read that header is track number 3. So you will get the request to read the data from track number 2. So you read that head should move from track number 3 to track number 2 to read the data. And then let me make a arrow in here so that you can understand easily. Then you get the request for track number 199. Then you need to read that head to moves from 2 number track to 199 number track. Okay, then it moves in this direction, and next then you need to write the 0 number track. Then again it moves from 199 number track to till 0 number of track, this way. And then again you need to read this 198 number track. Then it again move from 0 till 198 number track to read the data. And again it will get the request for one to track and read the data from 1 number track. Then again it will send back from 1 number track. Okay. Now let's count that how many track movement is needed in this situation. At first, header was in track number 3. So it goes from 3 to 1. So here is 1 track movement initially, and then 2 till 199. 199. And 2 minus 199 will be 197 track movement in here. And then 199 till 0. So here total, how many track movement? Here is total 199 track movement here. Okay. And then again it's received from 0 to 198. So again 198 track movement in here. And then again it is from 98 to 198 to 1 number track. It moved from 198 to 197 track movement. So if you make the summation in here, total track movement will be 700. I make this calculation in here. It will be 792 tracks movement. Okay, track movement in here. Track movement. So if track movement, let's say if track movement require 1 nanosecond of time, then total seek time will be 792 into how much time is required to actually to change this read head from one track to another track. It is 1 nanosecond. So it is 792 nanosecond. So this amount of seek time is required to read this request, to fulfill this, or we can say this fulfill this request. If you receive and request to read the data from track number 2, then track 99, and this sequence, then you need to to fulfill this request, you need 792 nanosecond to fulfill this requirement. If track seek time is 1 nanosecond, means that to change the head position one track to another track, it needs 1 nanosecond. So then at first you need to calculate the total track movement to fulfill this request, and then you will get the amount of how many actually, how much seek time is required. So this is the seek time for this request. This is the request that we're talking about. This is the request. If you receive the order to read the data this way, then this is the request. Let's change this requirement. You receive this request, this block of request, but you just change this order. Let's say at first you will read this 1, then 2, then 1, then 0, then you will go for 198, and then 199. Let's say this is 1. This how many requests? At first you will read here. At first you will read this 2, and then you will read this data from this 1, so 1, and then you will read this data from 0, so 0, and then you will read this data from 198, then you will read this data from 199. Okay, just you receive this. Here is same request. Just we change this order. Just change this order, previous order. Okay, just we receive this request, this kind of request at a time, and then we just rearrange in here. Then now let's see how many track movement is required. If you rearrange this order. Okay, if you rearrange this order in this way. Now initially track position at 3. Let's say initial track position. Initial track position is 3. So it requires, if you consider this order, so it requires from 3 to, at first it will read the 2 number block. It will moves from 3 to 2. Head will move from 3 to 2, and then 1, then 1. Then it will read the data from 0, then 0, and then again it will read from data from 198. So 198 till, let's say I just shown here 198 here, and then it will read the data from 199, last one 199 in here. Okay, it moves from this direction and that direction. So from here, that how many track movement is required? From here to here is 1, and here to also here is 1, here to here also 1. There is total 3. Or you can calculate from till here to here. It is same thing. From here to here, this is 3 number track minus 0. So here is total 3 track movement is required, plus a 0 till here. How many track is movement in here? 0 till 199. So it is plus 199 track. So in this order, you will get total how many? 202 track movement only. Okay, there is total 202. Let's say if you go for this order, you need 792 track movement. But if you rearrange the same order, you will get total track movement is 202 track movement. Is fine to complete this request. So if any algorithms can figure out to read-write the data by arranging this request this way, so then that will be the better algorithm than this one. Okay, previous one, because here is track movement is you need less amount of track movement, only 202. If each track movement require 1 nanosecond seek time, so here is total seek time will be 202 nanosecond. But in this case, it will be 792 nanosecond. This is very large compared to the 202 nanosecond. So some algorithm should figure out to rearrange this request, to fulfill the read-write requirement. requirement in this way so that the total track movement becomes less. So that algorithm is better than better algorithm, we can say. Okay, where actually you can reduce the total track movement of read-write head, means that consequently it will reduce the total number of seek time. Okay, so let's see some disk scheduling algorithms. You know that if you we already talk about different these scheduling algorithms, like different scheduling algorithms in our memory when we manage them, memory as well as memory, especially memory management system. So now let's see, it is almost similar as in here, but it is little bit different. Let's see, first one is first come. We'll study the first come, first serve. This is scheduling algorithms, or here you can say FCFS. Okay, FCFS. First come, first serve. This is scheduling algorithms. From this name, you can guess that what actually it will do. It will just simply the request that receive the SDD first will be served first. Or SDD satisfy the request at the order in which they come. Okay. So what would be the problems in what would be the actually benefit in here? There will be no starvation problems. Means that it is not a priority based algorithms. If it is priority based algorithms, there could be some starvation problem. But here is simply the process that comes first will be served first. So there will be the no starvation problems. Now let's say one example that how it will serve. It will works. Okay, how it will works. Now let's see. Let's one example is, let's say you have total you get a request from 5, 10, 20 and 30, and initially you read write head, let's say track number inside this track number 5. Inside track number 5 means that if you consider this thing, so this is 0, this is 1, this is 2, 3, 4, also 5, and kind of like this. Okay, 6 is the track. Okay, different track. Initially read-write head is in here. This is the initial position of read-write head. Initial position of read-write head. Okay, this is the track number 5. Initial read-write head is in track number 5. Track number 5. Here is the read-write position. Now let's see. At first, you need to read the track number. This request comes first, so this should be track number somehow in here 10 somewhere. So it should be in here. So now let's see that if it is so, you can like a draw. Then you need to read this track number 5. So track number 5 is kind of like this. Then you need to in here. So instead of doing this way, you can make it draw a line to make a track number. Okay, to make this track number. So this is the track. If it is track 3, you just make a right line in here, and then this is the track number 3. So this is track number 5. Instead of making this kind of stuff, you can simply put this line to make to actually consider a track line of this track number, or we can say this cylinder number. You know, this track number and cylinder number is always same. So how we can draw these things? Let's see. It is simple. So you can simply calculate, because to make this kind of stuff like whole, and then this way, it's kind of difficult to think, and then you can draw different track. It is also my drawing is not good, but you can make it by using usually what we do, we can make it by numbering this line instead of make a round shape like this way. So how many users you need to draw this line in ascending order. So in this request is smallest one 5. So you need to draw a track number line for track number 5. Track number 5. Then you need to which on this you need to draw a track number 10. for track number 10, and you need to draw then you need to draw a track number 20 and then 30. Also, here is track number, initial position is track number 5. Let's say if it is initial, let's say if it is 7, initial position is track number 7, let's say 7, then you need to draw the initial line for this initial position, track number 7. Okay, 7. Let's say 7 is the initial position of track number, initial position of read-write head. Okay, so just draw a line to figure out this is track. So to make it how many track movement, you need to go for ascending order. Okay, ascending order. Also, you need to draw this line for each request. Also, you need to draw a line for the track position, initial track position. It is 7, so you need to write a line, draw track number for 7 as well. Now let's see how many track movement is required for if you apply for FCFS algorithms in here. FCFS algorithms. Okay. Now let's say how many track movement is required. At first, I say that head position is 7. In here in this track, head is located current position. Position of read-write head is in 7 number track. So 7 should be, you need to mark a 7 in here, and then you read the request to read the data from 10. So you need to draw a line from 7 to 10. Okay. Also, you can make an arrow in here, the direction, and then you need a get a request from 5. So you need to draw a line from, you need to go for 10 to 5. Okay, 10 to 5 to read the data. Just opposite direction, you go for opposite direction from 10 number track to, you need to go for 5 number track. Then you request for the track number 20. Then you need to go for track number 20 from here to track number 20 to read the data, and then 20 to 30. Then 20 to 30. Now it is very easy to calculate. Let's say how many track movement here. Let's say total track movement for FCFS algorithms. So total track movements in here, you can see 7, and then this arrow, you just make it from this line to minus this line. Okay, 10 minus 7 is nothing but 3, and then you go for 10 minus 5, 10 to 5. So total movement is 10 minus 5. So total 5 in here, and then from you moves from total. You can go for total 5 minus 20. 20 minus 5 is 15. Also here is also 10. 15 minus 10 is 25. Also you can go for this one direction. This is one direction. So you can calculate this total track movement from here to till here. 30 minus 5. This is the direction, same direction. 30 minus 5 is 25 plus 25. Okay. So how many track movement is required? Here is required total 33. Okay. 33 movements is required. All right. So now you can see that how actually for read-write for FCFS algorithms. In case of FCFS algorithms, your seek time could be very high. Here you see that is 33 track movement, or if one track movement requires 1 nanosecond, then it is 33 nanosecond to complete to fulfill this request. But this thing could be changed because this is FCFS algorithm. So one request may come for, if you have total 200 track, it may comes from this 200 track first, then again 0, then let's say again it may ask for this 90 track, and then again request for 2, and then again request for 160. In that case, how it will be look like? Let's say your initial position, initial track position, initial read-write head position as let's say 50 number track. Okay, 50 track number 50. So how we can draw this? Here is request from this request. So you need to draw a line, track line, and initial position. I say initial position of track is 50. Now, how can you draw? Here is also 0 number track should be there. Also then 2 number track, and then then you need to draw the initial position as well, 50, 15 here, and then 160. Then you need to draw a line for 190, and then 200, 200, then also 200. Okay, 200. Now initial position in here, that first request from 200. So from here till 200, you need to move for till 200. Then 200 till, you need to go for 200 till 0. So 200 till again 0, this way. And then again you need to go for 0 to 190, 0 to 190. And then again you need to go for 2. That is for again you need to go for 2 number track. And then you get this request for 160. Then you need to go for again 160. 160. If you calculate this, it will be very high. Okay, because your read that head moves is kind of around zigzag format. Okay, if you figure out some algorithm that will read all requests by this fashion, all requests come in this fashion and then compilate these things. If it is like this, then this total track movement will be the very less compared to this zigzag fashion. Okay, it's actually revolving around, always around. So this kind of algorithm, FCFS, this track number, this 6 time could be very high. And nowadays, actually, we don't use this kind of FCFS algorithms. Okay, just for understanding purpose, you need to know about this FCFS algorithms, how actually it works. Now let's see some other algorithms. One is called this scan algorithms. This is popular, one of the popular algorithms, scan algorithms. Scan algorithms, or it is also known as the elevator algorithms. Elevator algorithms. Now let's see how it works. Actually, it likes an elevator. It goes in one direction to satisfy this all request, and then it goes to another direction to satisfy this rest of the to satisfy this rest of the request. Now let's see how actually it works. Okay, how it looks like and how it works. Scan algorithms, how it works. Now let's see, you have got a request from, let's say you have got a request from, let's say 20, then 80, then let's say 130, then let's say 40, and then let's say 190. Okay, this kind of request you receive. Now let's say how you would elevator. This kind of request means that you need to read the data from 20 number track, then 80 number track, also 130, 40, and 190 number track. Okay, then let's say how scan algorithms works. So you need to draw this line for this line, and also let's say initially you read write head is in track number, let's say track number 10. Track number 10. Okay, track number 10. So you need to draw all of these things. So at first, let's say track number between this is good to understand. Let's say track number 40. So you need to draw 20 number lines, and then also 20, and then 40, then 80. So between this we have 40 is on, let's say it is, let's say your initial read that head position is 50. Initial position of read write head. Okay, and 80, and then you need to draw for this line, or here you need to draw line for this 50 number for initial position of read write head, and then 80. Then you need to draw for you complete this one, and then 130 is fine, and then 190. 190. Okay, initial in here. So how elevator algorithms or scan algorithms will work? Scan algorithms is kind of simple. Let's say how it works. So initial position is in here. So either it can go this direction, either it can go this direction or that direction to read write, perform this read write operation. Okay, scan algorithms. So let's say it will go the higher order direction. Higher order direction means that it is in 50 number track. So it will go for this higher order is 80, 30 this way. Okay. Also, you need to go for this boundary line for this scan algorithms. Let's say you have total 200 track. So 200. So 199 will be it will 0. So 199 will be here. So this is the last boundary. If you have 200 total track, total number of tracks for a particular operator is 200. So it will be the boundary upper boundary is 200 and it will be lower boundary for 0. Okay, 0 till 199 track total there. Okay, now let's see how. So you need to fulfill this request. Okay, need this request. That let's say how actually scan algorithm works. Here I said that it will go either this direction to read or that direction. Let's say it will go this higher order direction, means that it will go from 50 till this direction to complete all of these requests. So it just scan through, it just go through, read that it go through all of this, okay, till 190. To complete it is in initially 50, so it will go in here to read this 80 number request and then 130, then 190. Okay, in this direction it is scan through all of this here request for higher order, whatever it received recently or currently right now. Then after complete this 190 is actually highest actually request from a cylinder number or track number. Then actually read write head actually for scan algorithm, it not stop in here. It will go through till its last outermost track or last track, 199 track. So it will not, even though it receives the data highest number of data for 190, but it will go till 199. Okay, so it will go this way. But important thing you need to know about that, this scan algorithms will not stop in higher to complete this higher request. Higher request is higher track request is 190. It will not stop in here. It will go till 199 or its last total number of, here I consider this 200. If it is 300, that it will move till 300. It's last, or we can say outermost track number. It will be outermost track number, and then it will be come back to fulfill these two requests. Okay, this is 2 and this is 2. Okay, this is 2, this is 2. So this is, this is kind of one direction order. This direction is first, it is scanned through this direction, and that direction is complete. So it takes definitely very less seek time complete with the in compare with the FCFS algorithm, because FCFS, it's move actually, it's revolving around, so it of course it takes time. But here is only straight line. Sorry. Here is only a straight line, so it should take always it will take the less track movement. Also, one thing you need to know about this, if when its track is moved this way, once it completes this reading from this data 80 number track, and it gets the request from by this way from this 90 number track, so it will complete this request and then it will move through like this way. Okay, when it comes in 133, and then it between 130 and 190, it also get a request from 160 number track to read the data, then it will complete the 160 request as well. And then it will go in here, and then it will not stop in the last request, then it will go through till the outermost track. Here, if it requests any request from new request, it will fulfill this request as well. And then when it comes back, it is same thing. If by this time, if it is request, here is only two things, two track needs to move, and then it will complete also by this way. If it gets some new request, it also complete this new request as well. because read write takes some time to read the data, and by this time SDT may request to read the data from some other track as well. So it will complete this request as well on the way. On the way, when it reads, when it gets a request, it will complete it, and then it will complete still 20. But also keep in mind, in 20 is the last track orders or track request. So it will not stop in 20. So it will all the way here to move, comes through at the innermost cylinder or 0 number cylinder. Okay. This thing is you need to know about for scan cylinder, scan algorithms. It's never stop in the largest track or lowest track request. It goes till innermost, also the outermost track, also innermost track. Okay, also on this way, if it gets any new request, it will fulfill this new request. It will always fulfill this new request, and when it's actually head is go back, then it will also fulfill this other request as well, and then again it will go back this way. So it's working this way. Okay? Always just scan like a elevator, go up and down. Okay, this way it works. So how many track movement in here? So it is very easy to calculate. Here is initial is 50 your and is 199. So it should be 140, 114. Okay. Yeah, and then you sorry. Okay, 149, and then 140 from here 199 till. So to fulfill this request, you need to calculate till here. Then you fulfill this request. Okay, fulfill this request. Here is kind of extra movement if you consider this. If it is 20, it's 20 till 20 is fine. So you complete this request. So here is 199 till minus 20. So total movement 1, and then 199 minus 20, 170. 79. Okay, 179. Okay, if you make this, so this is the total track movement is required for this request. Okay, if you consider some other algorithm, it will take more time. If you consider FCFS, it takes more time. Okay, now this is the scan algorithms. So do you have any questions for these scan algorithms? If you understand this scan algorithm, then others two others algorithm is actually very easy to understand. First one is, next one is the C-scan algorithms. Only difference is C-scan. Let's say C-scan how it works. Let me how C-scan is work. C-scan is work. C-scan, or it known as a circular scan algorithms. Okay, circular scan algorithms. Let's say how it works. C-scan works. Let's start from this 50, and then it will go back. It will read this all of this data, and then when it's go back, actually it doesn't, it won't read any data. It won't read any data when it's go back. When it's go back in this direction, when it's move back, it won't read any data. But when it's till 0 number cylinder, when it's come back, and this time it will fulfill these two requests, 40 and 50. Okay. Now let's see why you need to do this. When it's go back, then why actually it doesn't read the data. Why it doesn't read this data? So once it's go in this direction, it will just read this data. When it is reverse direction, it won't read any data. But when it's come back, then it will read the data. Okay, just in one direction, it will read the data. One direction, it will read the data. Read the data. In scan algorithm, when it's go back, it also read the data from this go back as well. But when it's go back, that time it won't read this data. When it's come back again, it will read this data for circular C-scan. So why we do this? If you consider in previous C-scan algorithms, what it does, it just read this data, and again it will read this data from in here. So what does it mean? That there is no uniform waiting time. Means that you access this cylinder first. When you receive some request from here, it will fulfill this request as well. So these two cylinder needs to wait some time. Needs to waiting for time. Why? Actually, it's always fulfill the request. The we can say this the cylinder that actually access the last time, or access the latest time. Okay, it always gives the priority. You see that this cylinder access this last time. Also, it completes the priority, completes this fulfill this request. When it's come back again, it may get some request from this cylinder. So again, it will try to fulfill this. Again, scan algorithm will fulfill this request. Okay, there is no uniform waiting time. Okay, for this kind of algorithms. Okay, so that's why actually C-scan is over this popular than this scan algorithm. But scan and C-scan both are very popular. Both are very popular. But C-scan is used due to it always provides a uniform waiting time for a scan algorithms. So when it's go back, it won't give any, it won't read any data. When it's read only in one direction. So some cylinder may not wait for a long time. That actually you can see for scan algorithm, some cylinder may wait for this long time because it's read the data for all both direction. Okay, so now how many track movement is required in here? It is simply simple. It takes little bit more than scan algorithms. Let's say from here to here, it is 149 in previous. Then it moves from 0 till 199 till 0. 199 till 0. So here it needs another 199 movement, and from here to here it takes another 0 to 40, so plus 40. Okay, so it needs little bit more track movement compared to the scan algorithms, but it provides you uniform waiting time. Okay, and disk scheduling algorithms. Okay, for disk scheduling, this can also use. All right. All right. Now our next algorithm. This is we complete the scan and C-scan. Now it's similar algorithms. It's called the look and C-look. Okay. Another is kind of it's called the look algorithms. Kind of look algorithms. Look is almost similar as the scan algorithms. So what it does almost similar as this scan algorithm. So what it will do? It will make start. Let's say its initial position is 50. So 50 till it will go till 199, 190. 190 is the highest request, highest track request. So what C-scan will do? C-scan is scan algorithms and C-scan algorithms blindly it will move till outermost. Outermost cylinder or 199 cylinder. Also, if it's request any get any request, it will fulfill this request in here. But for look algorithms, once it reaches the highest cylinder position is 199, it receive this request for highest cylinder position is 190 position. Once it's reached at 190 position, then it will look that if there is any request or any higher request is available or not. Here is no 199 or 198, so it won't go till the end. So from here it will again come back. Okay, it won't go to outermost cylinder like scan and C-scan algorithms. It just go till the outermost cylinder. Okay, highest track number, highest the track request that it received. Okay, and then again it go back, and then it will not from here it will see this lowest request is from track number 20, so it will stop here. It won't back to the innermost cylinder. Okay, it won't go innermost cylinder or innermost track number. Okay, this is how this look algorithms work. Okay, this way and this way. You just calculate these things, so you will get, I think, less number of track movement from. How can calculate this total track movement? By 190 minus 50, it is 150 plus 190 minus 20, 170. 150 plus 170. 150 plus 170. This is the total track number in here. So this amount of track movement is required for the look algorithm. So it needs little bit less track movement compared to the scan and C-scan algorithms. Okay, it may need. And then what is another is C-look. C-look is combination of scan, C-scan and look algorithms. Like like when it's go to till in this direction, so it will read the data. When it's come back, it won't read any data, so it will stop till the lowest request, and from here it will read the data, and then it will go back in again 40. Okay, it just read the data from this in here, so it won't go this. If from here it will look that if it's request, then it will go back in here, otherwise it will stop in here. Okay, it won't back to the outermost or innermost cylinder if there is no request. Okay, if there is no request. But in C loop, similar as previous, so it will, when it go back, it just read the data or write the data only in one direction. When it's go back, it won't read or write the data. When it's again come back in this direction, it will read the data in this direction. Okay, so this is how C loop works. Okay, I think you get this point. The scan, C-scan, loop, and C-loop algorithms. Okay. This is the all for this scheduling algorithms. So that's all from our file read write and then stuff. This stuff. So we have some couple of items from our syllabus. I think, let me share my screen. There is nothing to, I think there is nothing to draw in here. Let's see. So you'll get this PowerPoint slide from your module to take the preparations. So in our syllabus, we have some items like, one is the IO device. So I already upload this this couple of slides. Let's see what is the IO systems. IO system for operating systems. We already talk about different IO system already. Different IO system we know about that. You know, the SDD is one of the IO systems. Okay, your printer is IO device. Also, mouse is IO device. The disc, USB drive, or you can say CD-ROM, DVD-ROM. This is the IO device. Okay, some yeah. So IO system actually required an applications to take application IO request and send the request to the physical device. You know that. It's required. What actually IO system, IO devices? When you need to access this IO, you need to send this request. This why it is, whether it is ready or not. If it is ready, then you can send this to send the request to send the request to fulfill the requirement of this IO. Okay, or if you connect your USB device, you just get a request that to access this device, just send this request. You want to read this data, you just send the request to the IO device to read or to do the performance read write operations. Okay. All right. Now let's see that how many IO device we actually divide in two types. One is block types, another is character device. So what is the difference between block and characters? You know this in SDD drive. I already mentioned that in SDD drive, we read the data in block wise. We don't read data in byte wise. Okay. Once this, if a hard disk block size is 512 byte, if it is 512 byte, we will read the total 512 byte byte from SDD to your RAM or memory. Okay, we cannot read actually only one byte from this SDD drive. Once I get the request, okay, read the data from this block number 7, SDD block 7, byte number, let's say 20. So we cannot take this block number only 20 number byte of SDD block 7. We need to actually pull this whole of this byte. If it is block size is 512 byte, so we need to actually pull this whole operating system will do this whole 512 byte to send it to the RAM, and from this RAM, this 20th byte will be read by your CPU. Okay, so this is kind of this example of block device. Okay, this kind of block device read write perform in block wise, not a byte wise. Okay, here is example is SD drive, also is SSD, solid state drive. Nowadays we use in computers. Solid state drive, it is kind of SD drive, but there is not like any mechanical part like read write header kind of like this. So so SSD always, of course, read write will be the faster. It is similar technology as almost similar technology USB drive, but every block track is similar as that we study in SDD in file system in SDD. But here is no mechanical read write head is there, head in here. So this read write will be performed is more faster than compared to the SDD, previous SSD drive. Okay, but SSD's cost is very high compared to the hard disk drive. Okay, still SSD hard disk drive is popular due to due to its cost is less compared to very less to the SSD drive. Okay? Okay, one is block device, another is character device. Character device is a read-write communication with done by this block on the characters or octets wise, some arbitrary byte or byte wise we can read write data. So this is example for serial port, input output port. If you send this data from any serial port, this is character device. Example of character device, and then parallel port sound card is also received the read write, not a block wise, it is character wise. Okay? One important thing is IO devices. There is two things. One is the device driver. Device driver is software. You know that when you plug in new device inside your computers, let's say in printer, you need to install some driver software. So driver will actually communicate with operating system and also the device. Okay, and also another is kind of every device inside there is a device controller. It is a electrical circuit type circuit. It is controller. So each device, it has a device controller. Printer has a printer controller. Keyboard has a keyboard controller. Mouse has a mouse controller. Okay, so your device driver and also your device controller to communicate with the operating system. When it sends the data, the device driver manages this device to send this data to the specific input output device, and controller actually receive this kind of this information to control the input output devices. Okay. So here is two things. One is device driver as well as the device controller. Device driver is nothing but the software module, and device controller is kind of the electrical interface talks with between device driver as well as the operating system. All right. So this is some information you need to know for IO. Let me see that what is the next thing here. Our next part is some distributed operating systems. Nowadays, this is very one of the popular concept for distributing operating systems. So distributing operating system is nothing but by using this operating system, you can manage and control resources that are connected over the networks. Nowadays, many devices, your network, your printer, as well as some computers, workstation, and database servers, and everything is connected by these networks. And from this terminal or by using this network system, it will be private network, or it could be LAN and LAN one wide area network as well. It can connect it together, and you can perform a specific task. It improve the resource utilization. Also, of course, increase the reliability. If you have two different workstations, if somehow one station is down, then you can use the another workstation to smoothly do your work. Okay. So of course, security will be in this position is be high. There is scalability. You can add some, or you can reduce some devices depending on your budget. As well as flexible as well. Okay, you can do any. You can perform actually many things by using once you connect all resources together. Okay. Here is kind of resource utilization. You can share these printers. Nowadays, actually, when we go for office, So every printer, this printer is connected via the network. So all computers, you don't require to connect the printer every computer to every computer. Okay, there is one printer is fine, and then you connect together. And then of course you get the SD drives as well. If you have this common server, you can use, or some you can use as a virtual, you can use a network drives, and you can get it to the each of the users. Okay, you can share it. And then of course it will be of course cost effective. You don't need to actually go for to use this resource for a particular every user one by one. Okay? You can commonly use some resources by the distributed operating system. All right. Nowadays, network implementation in web and also online games, everywhere is distributed applications works. So real-time processing system like aircraft controls in that position, we use the distributed applications, parallel computation, also telecommunication systems, wireless networks. Here is kind of all are distributed in a single network. All are distributed. Distributed resources are work together to fulfill a requirement. Okay? These are some concept for distributing operating systems. And our last topic is, let's say it is cloud computing. Even though distributing computing is very popular, but nowadays cloud computing is more popular than this distributed operating. Almost the similar concept, but nowadays lots of service from this cloud provider actually. You don't need to do anything. You don't need to actually manage. If you have, let's say, laptop or your personal computers, then it is fine. You can get the service from different provider, and you can use their database service, or you can use their resources as well, the CPU, their operating system, and everything. You can connect to their server, and you can perform your tasks. You can do your tasks. And nowadays, many small businesses actually based on this cloud computing. Actually, it reduce the number of cost effectively, significantly. Sorry. And then let's say if you want to develop a new company, then what you need to do? If you go for this new IT company, you need to go for you need to at least some server for database server as well as the web server. You need to buy, and then you need to manage this server. There are lots of attack over there. Okay, cyber attack over there. So you need to maintain these services, manage these services. Also, this server needs lots of processing power. Power is another one of these factors. Also, it's maintenance, requires yearly basis maintenance. Okay, then cost is very high. But instead of this, you can set up your company like you can only buy some laptops and get this kind of database server as well, the operating servers, and then high processing power server to take it from this third party. So they will provide you some security and everything. Also reliable operation like some provider like the Amazon AWS. Okay, Amazon AWS, their service, also Microsoft Azure service, as well as the Oracle, they provide some cloud service. Okay, so you can take these services. It is very reliable. Also, moreover, it is cost is you can reduce your startup cost significantly if you take these services. Okay, that's why actually lots of company nowadays based on this cloud, they take the service from this cloud provider, and they reduce their cost significantly. Now let's say three different cloud concept for cloud computing component. One is the client computers, and then distributed server, distributed data centers, you can say. Client computers actually who take this service, and distributed server. So this server actually provided by you. You don't need to think about this. This is your computers. Over this internet, you will take this service from the service provider. let's say Amazon AWS. When I log into my Amazon workspace in here by using in here, so I'll get the operating system. I'll connect to the operating Amazon and their server. Okay, and then I can run my application over there. Okay, once I log in here, I'll get this same. Sorry, it takes time. So once I log in here, I'll get the Amazon. Amazon. I access this Amazon computers on server from the Amazon computers. It is very high processing powers. Okay, I can install my software over there, and there is a database, my database over there. So everything is in cloud. So I just from my PC, I just connect via this terminal. Then it is fine. Then after actually enter this terminal, I can do my work inside the Amazon their server. Okay. Okay, it is very secure because I don't need to think about the maintenance for this database server, my web server, and whatever I install inside this piece. I don't need to think about this. Amazon, they actually think about this kind of stuff. They manage everything for security and this side. Okay, this is how it can reduce a lot. It saves lots of time as well, lots of money as well. Okay, lots of effort. If you take the cloud service. All right. Now let's see. And then data center, there could be some data center. Yep, you can take the service from their data center or database you can install in here. And how, what is the different kind of services you can provide? Software as a service. If you don't afford to buy some software, but you can buy software. You can take this service. Let's say some software it takes. It may. Let's say Oracle. Let's say Oracle database server. It takes. It needs every month. You need to go for this registration also. Every month you need to yearly subscription is very high. So you can take this service Oracle service from some third party cloud computing like Microsoft Azure, also Oracle as or you can go for this Amazon. Okay, I want to use your Oracle database. So they will give you the access. So it will be very effective also. It will be very cost effective also. It will be very secure as well. Platform service. If you need to use some others Linux operating system as well as some others version of server, OS server, okay, operating Microsoft server, you can take this service from this third party vendors. Okay. Also, infrastructure service. Okay, many sources is by the form of storage. So we can nowadays this service is very popular. We take everything there. I save everything. Storage, they provide the hard disks. They provide that SSD drives. Network means that inside there I can connect my database. They manage everything. Okay, this infrastructure means that I don't. I just by using a terminal, I just connect to their servers and I do my everything. I have in their service. I just take this service for their database service, their computation means that I use their CPU computers and everything, their service, also software service. I need, let's say I need to run my to run my programs. I need Visual Studio software. They have I need to just pay of them. It is very less fee if I directly buy from Visual Studio from Microsoft, from the Microsoft. Okay. So I can take all of these services from a cloud provider. Okay. So nowadays it is very popular. So it can be public, it can be third party. So you can take it from a third party or from everywhere. You can any places you can connect over the cloud. Also private. If you want to make it the private service, that service from a cloud provider, so they will give you more high secure, that nobody from outside cannot enter your space or enter your service. Okay. Also hybrid, you can go for a public as well as a private. Okay, some part will be the public part, you can access from anywhere from this world. Some part you need to access for privately, okay, especially for database, and then database or internal website. Usually, sometimes we don't need to give the access from this outside world for security purposes. So cloud provide this kind of infrastructure as well. Okay? Hybrid. So some part we can access, but some part we cannot. It is, of course, it is very cost saving that I mentioned. This is the very important factor. It is very cost saving. If I buy server, powerful server, as well as I need maintenance cost as well as the service for different software cost, it will be very high compared to the cloud computing. Also flexible, whatever service I need, I just ask them, they will just give me the service. If I don't need, then I just cut off, so I can save up this money. I can save the money, and then again, if I need, I can again contact to them. They will provide the service. Okay. Also, enhanced security. They provide actually a very high security. It is actually we cannot think about for individually. So they provide lots of they have lots of secure tools they develop already. Also, they have some encryption method or access control methods. Okay, that we as an individual companies we may not think about at the beginning of time. So we can of course if we take this cloud service from this cloud computing, of course it will provide the best security for your database server as well as the web servers and everything. All right, that's all for cloud computing as well as the IO, as well as the some others is IO, as well as the some others part. Other part is distributed computing. So that's all for our syllabus. Syllabus for advanced operating systems. All right. So your exam will be similar as the previous, like MCQ and true false type. Total 40 question again I mentioned, and then you will get total 60 minutes. So it will be next Tuesday, 16th of May. So in Thursday you have another class. So I'll be in here. So if you have any question, there will be no classes actually, user classes, but I will be here. If you have any questions, any topics you can discuss with me. Thursday I will be here. I'll be logging to the Canvas. You can also log in. You can join. If you have any questions or any question regarding any topics, okay, or exam, okay, I will give you answer. No problem. I'll be in here. But till now, today actually we end our syllabus. And thank you very much. And I enjoy a lot. Actually, I online course. It is difficult, not easy to manage this course online by online. Try my best to give you the classroom flexibly, classroom type of actually feelings like classroom types. Yeah, so but I try my best from my limitations and everything, yeah, for online. Okay, have it. So we can end here today. We're almost running out of our time. And if you have any question, you can ask me. You can email many times. Also, I will be here for Thursday as well. Your exam is 16th of May, next week, Tuesday. Okay. Have a great evening, and have a good luck in your final exam. Okay? Bye.